Thank you. Like several others, I normally wander and bounce, but I'll try to not make Cooper crazy. I want to show off some really amazing high-tech thing that I've discovered. There's some sort of black magic with this because there's a generator and you wind it once a day and the screen never goes dark. So when you give presentations, it keeps telling you the time. It's genuinely amazing. So the past, present, and future of InfoSec. As mentioned, co-founder B-Sides, work at Tenable. We have a growing office here. It turns out this is a cool place for tech people. Look at the audience, that kind of shows it. But before I dig into this, you all know more than I do. But together we know more, and this is a theme that's come up, whether we're talking about certs or other things. When we share, things get better. So here are some things that I've learned. First, we're going to talk a little bit, explain what's happening. I've built a fairly complex timeline. Hopefully I'll be able to work through it in a way that makes sense to you, focusing on two critical components of what we do, computers and people. And so the timeline looks something like this. And once upon a time, on the then end, we had fairly simple systems. Single user, single process, and it was possible to secure them. We didn't, but it was possible, at least theoretically. Early OSs had no security, and then we got this brilliant idea we would secure systems. For anybody old enough to remember or have read about Debian's 10x, that was designed to be secure by default. And they made some of the dumbest, simplest mistakes you can imagine. But they headed in the right direction. And then things got trickier, and we have job security. The more cynical of us, me, sometimes look at that as not a timeline, but, variation. Andy Jakewith years ago coined the term the hamster wheel of pain. I'm a little more optimistic than that, unless you follow me on Twitter on a Monday morning. But first, why look back? Well, like it says over here, it says that on the wrong mirror, because people are on the other side of the road. But objects in the mirror are closer than they appear. The past comes back to haunt us. So I want to start a little bit talking about some people and some ideas. And when we talk about information security, we have to start by asking, why do we need to secure systems? Why do we need to do this? Well, it turns out we have this new thing called attackers, people that attack our systems, and this is new. In the communications age, in the digital age, in the wireless age, we have new problems, like Francois and Louis Blanc in 1834. The French had a semaphore system that crisscrossed the country. It was for government use only. It was a fairly straightforward semaphore system. Towers, people looking, out the next tower, and they would relay the messages along. These brothers realized that if they could put a message on the system at a port city, for example, or in a government location, they could signal each other and get messages ahead, hours or days ahead of anyone else, and they could game trading systems and other things to their profit. It worked well until they were caught, they were arrested, and for some of you that have been doing this for a while, then they ran into the little problem. It was not illegal. There was no law that allowed them to be prosecuted. They decided it was a bad idea to stay in France, and they left, but, this is 1834, modern hacking. Let's move forward to modern wireless hacking. He's often credited as being the first hacker. Neville Maskelyne, a dandy-looking gentleman. He was a Victorian-era magician, inventor, and hacker. He invented the pay toilet. Victorian England, they wanted to be able to have nice toilets for the nice people, and he created a way to do that. But he's here because in 1903, Marconi was demonstrating his secure wireless telegraph. So the way it worked was Marconi had some potential investors in a parlor in London and an associate reading messages as they came off the wireless So Marconi was on the other end of the country, sends the messages. Maskelyne gets in the middle, sends messages ahead. Any of you that have done like Morse code or any sort of messaging, you know how you get into this state where you're just processing what flies in front of you. Well, his associate, Marconi's associate, had read most of an obscene limerick ridiculing Marconi before he realized he should probably shut up. So yes, attackers are why we have to defend. Let's come forward, so we talk about computer security. That means that we, of course, need to start by talking about Alan Turing. Okay, let's talk about this guy, Alan Turing. We're not going to dwell on this because you guys know the Turing story. If you don't, there are some liberties in the movie that he was in, but it's a good one. It should pique your curiosity a bit. But one of the people I like to talk about is this dude, which I doubt that any of you have ever heard of. This is Doc Keene. He was called Doc because he carried a doctor's bag, but he kept his engineering tools in it. The point about Doc is that this dude was brilliant. Do you suppose he created engineering diagrams that somebody could actually build something out of? He spewed ideas out that required an engineer to turn them into something actionable. Does that sound like what any of you do on a day-to-day basis? And by the way, he isn't the guy that soldered things. He supervised the people that were burning their fingertips or whatever, making that original computer work. This goes down a rabbit hole I won't go into in this presentation, but there are other people that play a role in that particular part of the thing. But I wanted to start with a couple of historical figures, but then let's move a little bit more modern. I'm not much of a futurist, so spoiler alert, the end of this probably won't startle you. But let me try this. If I were to say in some places right now what I'm about to read to you, people might not think it was true. You guys will accept it as something you probably have known for years, but the computer will touch men everywhere and in every way, almost on a minute-to-minute basis. Every man will communicate through a computer whatever he does. It will change and reshape his life, modify his career, and force him to accept a life of continuous change. Willis Ware told us this in 1966. Dude was a little bit ahead of the curve. Turns out he was right. He worked during World War II on classified radar systems and the automated identify friend or foe, the IFF stuff. Then spent a 40-year career at RAND. He's here because of the Ware Report. Started in 67, finished in 71. It has faded in some ways, but not in others. One of the most interesting things about him was because he had that insight of the power of the computer, he also was one of the first people to sound the alarm about the significance of the privacy implications of this. He's the one that pushed, in the United States, we got our first privacy law at the federal level because of Willis Ware pushing Gerald Ford. I'm not going to make any Ford jokes, never mind. Anyway, the report, most often known as the Ware Report with the sexy title Security Controls for Computer Systems, sort of set up the thing that became like the Orange Book and the Red. But this was the beginning of the U.S. government and the military doing it. And like I said, it's dated. It's completely obsolete. There were these observations like, certainly security control will be cheapest if it's considered in system architecture prior to hardware and software design. Here's one that's been touched on before today. User convenience is an important aspect of achieving security control because it determines whether or not users tend to find ways to get around, ignore, or subvert controls. This diagram is completely obsolete unless you change a couple of words. Maybe change some of the pictures, but the idea that you have to trust your operators, that there are ways to get into the communications path and intercept things. You don't know what's out there. Crosstalk, remote. These things go back to the semaphore system. What if you can't trust the line of sight? That semaphore system, the way they hacked that was really simple. You send a string of letters. But if you make a typo, there was a command that says, ignore the last letter. So they would put a string. They would bribe somebody to put a couple of letters in and back them out. So whoever read the message saw nothing wrong, but the person watching at the other end would be like, there's a B backed out, an S backed out, so that means whatever, right? This, 150 years later. This is still a thing. Actually, that report is worth reading. It is not completely insightful. Some of it is obsolete, but a lot of it is really relevant. This guy I'd like to talk about too, Bob Abbott. Anybody fan of the movie Sneakers? All right. Everybody on that attack team was based on one of Bob Abbott's teammates. He is the person that built the first, what they called red team at the NSA. It was far from modern red teaming, but it was the first, probably vulnerability assessment is what we would call it now. But his team actually pushed it, because the way you do vuln assessment at NSA or GCHQ or similar is a little harder than the way we tend to push our own systems. So everybody was there. At the end of the movie, Darth Vader came out and had his little cameo appearance. His was named Bernard Abbott. That was a nod to Bob Abbott, who was a consultant in there. Anyway, the thing that he led, all sorts of stuff. He wrote the first 24/7 operational multi-user, multi-thread OS for Cray class computers. He did some amazing physiological monitoring systems for healthcare. Arguably the first person to step out of security being what you did for the government or a major corporation into a consultant role. Pretty strong case can be made for Bob was the first security consultant, stepped out of government use. Led a project called RISOS, the Research into Secure Operating System. It ran from 71 to 76, sort of picked up from the Ware Report. And another one of these really sexy titles, Security Analysis and Enhancements of Computer Operating Systems. This report is dated. Unless you're like me or you want to dig into the history, this one's a little bit more of a slog. It's not quite as relevant, but there are some pieces that will make you cringe. This document will be especially useful if it reduces the current tendency for the same security flaw to reappear repeatedly in different systems. Ouch. They came up with 7 key problems, and I'm not going to read them. I'll just click through them here, and I'll let you, because we've solved these, right? 7 key concerns that they identified in the early 70s with securing an operating system. So, incomplete and inconsistent parameter validations, we got that one nailed. Privileged and confidential data that's implicitly shared when it shouldn't be. This is one, if you're not aware of this, they were worried about race condition, time to use, time of checkout versus time to use at that time. Now, it sort of makes sense there with slower processors. As we have, what's a computer now? It's a whole stack of computers. This is, we haven't solved this one. I'll just look at my friends from Duo as we read the slide about inadequate identification, authentication, and authorization. We might still be fighting that battle. Limits that don't really work, and then the one that catches them all, right? Now, this is one of the places where it's really easy to get into this, but I would like to point out that we really have lifted a lot of these problems out of operating systems. They're not common. We do occasionally find them. If you can tolerate a lockdown operating system like iOS, we've largely lifted these right out of there. Now, we've dumped them on the application layer, so now they're just everywhere, but at least we did get them out of that. History of computer security. Let's come forward a little bit. I wasn't going to put him in, but I decided to pop him into this because it's irrelevant. He's why when I said the United States CERT, the worm he created wasn't supposed to get loose. SPAF did the forensic analysis. Well, why do you do forensic analysis if you have the source code? Because it wasn't supposed to go wild. Side note, his dad was at NSA at the time. FBI had to go in and tell his dad that they were rolling his kid up at the university. I have heard about that day from folks that were there at the time. FBI normally walks in with a swagger. FBI does not walk into NSA with a swagger. The guys at the gate at Fort Meade, they're not mall cops. Let's just leave it there. I like to talk about them not only because certain that's relevant here, but also in the industry, those of us that hang out in the hacker crowd, there are some famous reformed hackers, and I'm not going to name names or make fun of Mitnick. So the kid did this. He was the first person convicted under the Computer Fraud and Abuse Act. Possibly the last person justly convicted. No, but anyway. What did he do since then? Right? Most people only know of him for this. Well, he went on to co-found 2 companies. One of them was ViaWeb, and the other one's Y Combinator. Y Combinator continues to be an incubator for the tech and security industry and has been for a long time. But that's not where it ends. He joined the faculty of MIT, and since 2006, Robert Tappan Morris has been a tenured professor of computer science and electrical engineering at MIT. If you want to talk about reformed hackers, this dude was pretty solid. So let's jump into a more modern report. This one is, 8 years old now, but it came out of MITRE. As long as I'm being a smartass. I am so old that I remember when MITRE was relevant. Steve doesn't like it when I say, I have friends that, anyway, the science of cybersecurity. They thought, hey, let's take a look at cybersecurity and approach it scientifically. Most important attributes would be the construction of a common language. We've already had that conversation today, right? Set of basic concepts about which the security community can develop a shared understanding. So I've been in vendor space for 10 years. I'm part of the problem because the people on the sales side of vendor world love to make shit up. All of the artificial intelligence that you're seeing is machine learning at best. If you don't believe me, look at what artificial intelligence meant in the late 70s. Throw your artificial intelligence system trying to convince it to try to write natural language. It'll fall apart. But it can do things. We just need to not lie about what we're doing. But precise definitions matter. Until there's a precise set of objects that can be examined carefully and clearly, we're not going to be able to improve the level of rigor. Here's the battle that we face. You've got to patch your stuff today. You have no choice. But let me ask, my knowledge of securing IIS-4 on NT4 is not terribly valuable today. My skills at mastering, let's make the old people twitch. My skills at mastering WINS replication in an NT4 domain are not relevant. Yeah, oh yeah, there we go. See, I say bad things. I should have had that disclaimer. On the other hand, if we're just focused on the deep problems, which is one of the battles we have between being in the trenches and academia, or MITRE, where, they get to be propeller heads, that doesn't solve the fact that I've got to patch my shit today, right? It's a struggle we've got. So they came up and said some things, and a lot of people nod at this stuff, and there's a lot of stuff we can learn. Meteorology is imperfect, but you live on an island in the North Atlantic. The forecasts are better, and it's good. I've lived on the Atlantic coast of the U.S. for over 40 years now. I like the fact that hurricanes aren't a surprise. Well, one of the ones I like to talk about is immunology, because people like to talk about this, and there are a lot of lessons there. But remember this when we're talking about biology and science and survivability and security. For a population to thrive long term, it can make a lot of mistakes, and as long as you're left with one breeding pair that makes it work, we're okay. Does your company get to be one of the 2 companies that survives in the universe? That's probably a little harsh for most people. But it comes back to some things we've talked about. We need standardized language. Self-defending hardware and software, we have so much compute power that we waste on dumb stuff that we could actually be doing some of that. Let me jump forward to somebody else, Steve Lipner. He was at MITRE, and they told him to do computer security stuff, and he said he didn't want to. And they said, you've got to, you're an intern, and he said, okay, I will only do this until you hire the right person. Many decades later, from his work at the Orange Book to one of the people that created the Trustworthy Computing program at Microsoft, he's still doing it. What's really interesting, I'm not going to dig too deep into it, but if you can find a copy of this, The Birth and Death of the Orange Book, Stephen honestly disassembles what was wrong with the Orange Book. Just a quick quote, if the objective of the Orange Book and the NCSC was to create a rich supply of high-assurance systems that incorporated mandatory security controls, it is hard to find the result was anything but failure. We need to go back and look at our failures and write about them and learn from them. What a crazy idea. Let's wind this down quickly. But the history of computer security, over there, computers were rare, and they were terribly expensive. And the people that operated them were clerical, and then a little more than clerical. The computers were expensive and rare, the people were cheap and plentiful. At this end, it is cheaper to put full computers in everything because computers are effectively free. Why would you create a small IoT device running something like QNX, which we could actually make provably secure, when I can effectively do it for pennies for a chip that will do it? However, the people, which works for most of us in this room, are scarce and expensive. I like that part of this progression, that we're scarce and expensive, but it's tricky. And what happened in the middle? A handful of things. We consumerized computing, we consumerized software, and then probably the most terrifying thing, we consumerized the creation of software. And that comes along with the commoditization of all of these things. And that probably would have been okay if we hadn't, starting here and accelerating into the future, connected every stupid thing on the planet. And that's what we did, and that's why, again, we have a lot of things. In the future, so I'm not that bright, so I'm going to go back to one of my favorite authors, Douglas Adams. I didn't foresee the internet. But then neither did the computer industry. Not that that tells us very much, of course. The computer industry didn't even foresee that the century was going to end. He's making fun of us from beyond the grave, because this still hurts every time I see that quote. 2038's far enough away, don't worry about it. I'm no futurist, certainly not a Willis Ware. I'm certain of a couple of things. Every time we do something new, we're going to make the same old mistakes. The calmer heads are going to say, hey, containers are different, but we have learned these lessons before. We learned these lessons when we ran a wire from the mainframe to a terminal in the other room. And people didn't like it. And then the other room was miles away. And we went through client server and virtualization and cloud and containers. And there were mobile devices. There are new lessons every time. There are new opportunities. We don't want to give up the opportunities, but somebody tries to sell us something new every time. And yeah, we have to tune the old ideas, but do you want to turn the internet off? I mean, a lot of us some days do, right? Let's be honest. But the advances that we make, I think most days outweigh giving up on everything. IoT, we've got, it's Windows 98 all over again. Everything's connected. It's insecure and unsecurable. So all of that stuff that we had to give up on, like agents, took up too much power. Well, now if we don't install agents a few places, there's no other way to see into containers and virtualized environments. If we don't monitor the networks, even though things are largely encrypted, although nowhere near as much as should be, we don't have any idea what's going on. Let's not freak out. Let's dig out our NT4 days stuff and go somewhere with it. But this is where I'm supposed to make some great, amazing prediction. And I'm not going to, but I'm going to tell you my thought and my belief and the way I've spent most of my career once I got out of the bottom level of trenches and was able to share things that I had learned. The future of computer security, information security, cyber, if we must, if it's going to be successful, it's going to be because we share information in this room, in this community, globally. We learn and share, and if you're new at this and just discover that you can test a mail server with Nmap, there's somebody that hasn't learned that yet, and you're going to bring a unique perspective to telling that story. It's why I put the time into B-sides, and it's why when I've given them the opportunity to amuse, entertain, whatever, I jump at the opportunity when I can, because we need to work on this. And we need to work together, or we're screwed. I mean, we may be screwed, but let's be less screwed together, right? Let's do that. Several of the references here are from another one of my projects, The Shoulders of InfoSec. It's an ugly wiki, which I guess is a redundant statement, right? Ugly wiki. Lots of folks that have made the industry what it is are in there, and folks who haven't heard of. Interestingly, it's called The Shoulders of InfoSec, based on the Newton quote, which he borrowed from one of his mentors. If I've seen further, it's by standing on the shoulders of giants. That's kind of humble of Newton to say that. He didn't realize how profound an impact he would have on us, but he had that. But I call it the shoulders of InfoSec, not the giants of InfoSec. Why? Because you don't have to be a giant to provide a shoulder for somebody else to stand on and help someone else in this industry. I believe, in fact, that you don't have to be a giant to provide a shoulder. Providing shoulders for others to stand on to see further than you have is one of the things that makes you a giant. And with that, this is not the end. It's the last talk of the day. It's the beginning of some socializing. It's the beginning of what you do. Normally, every now and then I'm like, man, that's going to be a hard act to follow. I got up here this afternoon. I had 10 hard acts to follow. There's stuff that you've learned. There are people you've met. It's the beginning of that part of this. So thank you very much.